Hi, thanks. Hi, thanks so much. Before I get started and kind of talking about what we're all going to talk about tonight, I just want to give you a little bit of background of who I am. I'm actually an anthropological archaeologist, and I know what you're all thinking right now. You're like, wow, anthropology, that is the discipline that is not at the forefront of the open science movement. You're absolutely right. We have a lot of colleagues that are doing their best in anthropology to kind of bring this movement into the sphere, but for me, that was something I really struggled with when I was doing my graduate work in early 2000. I was looking for these kind of values of science that I was the ideas of science that I thought I was practicing and was having a tough time kind of coming to. And so really what I'm trying to say to you here is that I understand if you're in a field where open science methods and it may be something new to you. This was something relatively new to me as well, and it's something that we're all growing with together. And so really what I want to talk to you about today are these kind of three main topics, right? So what is open science? I know you've gotten some other lectures on what that is, but we're going to talk a little bit about what it is, what does it really mean to have open science or to do open science. The Center for Open Science, the organization, the nonprofit that I work for, what we do and how we help achieve those goals of open science, and then SCORE, Systemizing Confidence of Open Research and Evidence. What is it, and what are we doing, and then where do we hope to go with all of that? So what is open science? What does it really mean? And yeah, so it's the openness and reproducibility, but it's about knowledge accumulation by sharing practices, right? And it's aligning scientific practices with values. And that includes open access, so access to journals, trying to get behind the paywall so that we're not always siloed. And for archaeology in particular, it's kind of an echo chamber of publications, really kind of hearing ourselves speak to ourselves over and over again. Open data, making data and databases available, not just the kind of clean data, but also raw data. And then open methods to do data collection. How are you doing your data collection and your analysis and the syntax that goes with that? But this is not common practice in the research fields, and because it requires additional commitment. But this is also not a discussion that's relatively new. So Robert Merton published the values of science, and he broke it down into norms and counternorms. And he's a sociologist and was really interested in scientists as a social group. And so what he was trying to ask is, how are we learning things about the world, and how are they supposed to be? How are these norms of science or values of science supposed to be? What are those? And so communality, open sharing versus secrecy or closed. Trust me, I'm a scientist, I'm the expert in the field. Universalism, evaluating research on its own merits, versus the particularism of research by reputation or the reputation that you build. Distinctiveness, motivated knowledge and discovery about getting it right, versus self-interested kind of science as a competition, potentially even just how many publications you're able to get. Organized skepticism, considering all evidence, even those that may counter to what your norms and expectations might be, versus the organized dogmatism, investing in the career to promote one's own theories. And then, of course, quality, getting it right versus quantity. So where are we with how this is being applied? So Anderson, Martinson, and DeVry in 2007 had a questionnaire that they posed to early and mid-career researchers who had gotten grants from the NIH. And we're talking about 3,200 participants in this. And so the first question they asked was, what's the ideal that you as a scientist follow, right? And so it looks about 90% of the researchers who answered that question said, I obliged by the norms that we just discussed in the values of science, openness, transparency, really kind of fostering inclusion. Probably about 10% maybe has a kind of a mix of the norms and the counter norms, and a small percentage admitted to just really kind of committing to the counter norms. So then they ask the second question, which is, okay, so those are your ideals, but what are you actually doing? What are the perceptions of your own behavior? And so we see a little bit of a drop, right? So about 60 to 70% say, nope, I'm still actually really engaging with these norms. We see an increase, probably about 20% of researchers who are saying, I'm probably doing more of a mix of the two. I kind of want to do this ideal, but I'm doing a mix. And we start to see that increase of researchers who are admitting that they're actually playing into the counter norms. Okay, the last question that they ask to the scientists are, all right, now tell me what you think about the people down the hall. What are they doing? Are they doing the norms or the counter norms? And you see here that suddenly the perception is, in fact, everybody is participating, or a good majority of them, right, are participating predominantly in the counter norms of what the values of science to mean. And so it makes it really difficult, right, when you have all of these variables and this perception of what you're supposed to be engaging in, but, or the ideals of what you're supposed to be engaging in, but then the perception of what everybody else is doing. And it makes it difficult to engage in these open science behaviors or open science habits, right? We've got these beliefs and ideologies and achievement motivations that influence how we interpret our research. And that even if we're trying to resist those motivated reasonings, that we may not actually see it in ourselves, but we can, even if we can see it in other people. And so the biases that might influence us can be anything, right? So pick your favorite, the hindsight bias, or even self-censorship, right? Nobody in my field, or everybody in my field, does X to the data before they kind of share it. So everybody knows that we clean the data this way, so I'm not going to share it that way. It is a self-censorship in terms of how you're going to proceed with your research. There's minimal accountability. You really don't know much about my lab or my research until I've been published. You haven't been able to kind of look behind the curtain. And then concrete rewards beat these abstract principles of getting it right, publications being kind of upfront on that. And then lastly, I'm busy. I'm busy, you're busy, we're all busy. And now you're suddenly throwing or overwhelming me with all of these different ideas about kind of practices that I should start to engage in. And if I start to move in that direction, my productivity is going to sink, and the productivity of my collaborators is going to sink. So I'm going to do the best that I can, and here's hoping that I can get it right. So what I'm arguing here is that essentially incentives are for getting it published and not getting it right. But the open science movement is really about shifting that approach to making it trust me, away from trust me, I'm a scientist, to here, let me show you. So we can all engage in that conversation. So this kind of leads to, all right, well, how are we going to do this? And then why should we do this? There's different ways of engaging this. Some of you may already be engaging in a number of these practices. Some of you may not even know that you're engaging in these practices. This is a conceptual model with the center kind of being the most transparent of what you can engage in and how to do it by author's request. So if you reach out to an author and say, hey, can I see your data? Can I see what your methods were? Would you be willing to share your code with me? Is a great way, and what I think many researchers do, but it leaves the onus on individuals to reach out. And in some cases, you don't hear anything, just crickets, or you just get a blatant no sharing. There's also ways to share materials using third parties to put your data, or excuse me, your materials and your processes up. There's the shared analysis. So what's the syntax in the code that you're using for the analysis that you're conducting on your data? That includes your R code, your SPSS code, G-Power, pick your favorite statistical analysis method. Sharing the data, so sharing the database, sharing the raw data, not just the cleaned or analyzed data, but showing all of it. And then pre-registered reports. And I'll talk about this again a little bit later. But for those of you who aren't familiar with pre-registered reports, this is where you state your hypothesis, your study design, your analysis plan, your methodology, all before you conduct data collection. And you do this to kind of put a line in the sand as to this is what I'm going to be working on my data on, and frankly, to keep us honest, to report on what we say we're actually going to be studying in that particular case. What's also really great about the pre-register report is that it goes up for review, and so that you can begin to engage the reviewer process earlier. So for those of you who've gone through the publication process, the peer reviews come at the end after you've done the studies. And personally, I've had some that come back and say, you should have thought about these other things before you did the study. You're right, I should have. This is an opportunity for that engagement to occur at an earlier stage and actually make your research stronger and better. So what do open workflows do? They can do so many things that personally, when I was as a researcher really looking for in graduate work, that included, transparency, accountability, things that you've probably already heard before, but it really does foster collaboration and inclusivity, as well as increasing innovation. So why should we be doing this? Well, I think one answer is for the discipline, right? The research that we do can be enhanced and benefited from this open workflow. We can begin to engage with each other. But remember, I'm an anthropologist. And so the step that I always look at is the reason I got into archaeology or anthropology, okay, yeah, it's fun, and yet I'm great to have at parties when I say I'm an archaeologist, but it was about a larger human problem. It was about the social problem, and something that I still believe very wholeheartedly, that learning about our history only makes us understand our future and where we can go from there. And it is that larger problem working with our communities, be it you're doing social networking, economic markets, trying to do better for education of pre-K. We're all in this research to help that kind of larger human problem and answer those questions. Don't believe me? That's fine. Pew Research Center just had a study come out last week showing the trust and mistrust in Americans in scientific experts. So the good news is that we are on par, scientists are on par with trust in the American public, or American public trust the scientists, same as military. And we are trusted more than politicians and clergy. This is good. However, only 35% of Americans have trust in scientists. And that's up 16% since 2016, thereabouts. And no more than 2 in 10 Americans actually think that scientists are being transparent about their conflict and interest with industry, either some or all of the time. And so we're not doing a very good job about gaining that trust in the public who are essentially helping kind of guide and direct policies. And the best quote that came, one of my favorite quotes, I should say, that came out of the report, really hits it home, at least I think it does, is, quote, "When Americans gauge the kinds of things that would influence their faith in scientific findings, the verdict is clear." Dramatic pause. "Open public access to data and independent committee reviews inspire the most confidence in scientists and boost their trust in research findings." So doing the open work, engaging in the open workflow, not only helps benefit you as a researcher, helps benefit the discipline that you work in, but it's actually something that the public's asking for and wants to engage in as well. Enter the Center of Open Science. This is a nonprofit tech startup group that was founded in 2013. We're based in Charlottesville, Virginia. And the mission is to increase openness, integrity, and reproducibility of the research. And really what we're trying to do is align the values of scientists with their practice. And so the way that we do that is we build technology to enable via infrastructure. We have incentives to embrace. And then we have evidence to encourage change in behavior towards open science. we don't want to tell, and we don't tell scientists or researchers how to do their work. You already know how to do your work. But what we're trying to do is get you to look at your entire workflow, look at what you're engaging in, and recognize it along the entire life cycle of a research project. And just because you show one part of that research project or that life cycle doesn't show the entire part. And so it's about understanding that the problem here is dissemination. How do we get that information out? How do we make things accessible? And so where the Center of Open Science comes in is one, technology infrastructure. One of the things that we do offer is called the Open Science Framework. It's a free and open source web-based resource that connects and encourages open research among researchers and encourages collaboration. We also have incentives to embrace, and these are badges that can get associated with your publications, your preprint, your pre-registrations that encourage and acknowledge the use of these particular open science practices. Transparency and openness promotion top guidelines. Our policy team is working with funders and journals to guide implementation of many of these open science methods. And so we engage all of these aspects, but how do we know if we're going in the right direction? And that's where the department that I work in is meta-science. We asked the questions and gather the evidence. So one of the things that you may have already talked about is this reproducibility project in psychology. We refer to it as RPP, which was done, I guess, about 6 years now, where the Center of Open Science conducted replications of 100 correlational experimental studies from three psychology journals, and they were using high-powered designs as well as the original materials when available. And so these graphs are pretty remarkable, at least they were to me the first time that I saw them, that the replication effects were half the magnitude of the original effects, representing a substantial decline, but that 97% of the original studies that showed significant results at a 0.05, we were only able to replicate 37% of those at 0.05, the same direction. And so this ultimately began the question of what are we doing and are we doing it right? What is this replication crisis really about? And one of the biggest projects that we're participating in is SCORE, gathering more evidence to see whether this is a problem, and not a problem, but whether this is something that we can see across the fields. So systemizing confidence in open research and evidence, that's why we call it SCORE, is a program that was innovated and initiated by DARPA, which is the Defense Advanced Research Project Agency. It's essentially the research arm of the DoD. And they're just very interested in advancing the assessment of scientific, or rather the credibility of scientific claims. And what DARPA is interested here is they want to know what stuff science is really sure about. And how do they know that? And then how do they know that they know that? And this is coming from a place where they want to quickly assess the social behavioral science and leverage that research for the purposes of national security. So, but they're still asking these same questions, which is that, they see, we all, and we've seen this before, the same words are being used in titles or articles, but different units of analysis and different theoretical constructs are leading to dramatically different notions of causality. And so that makes us question whether SBS is reliable. Doesn't mean that it's not trustworthy, it's just maybe unreliable. And one study that I think is really interesting here, kind of highlights that phenomenon, is this study that was done a few years back 29 researchers were given the same set of data and given the same question, which is, do soccer referees give more red cards to dark-skinned players than to white-skinned players? So 29 researchers consisting of 61 analysts participated with a wide range of analytical approaches. And what they found was that 20 of the 29 found, in fact, that cards to dark-skinned players, referees gave more cards to dark-skinned players than to light-skinned players. And 9 of those didn't find any correlation into it. So on the one hand, it's saying, well, clearly it has a lot to do with your analytical methods. But on the other hand, it's saying, wait, there's something there. There is a real bias here. What is that bias? And not a single test would have been able to show you that in the same way that this kind of study really hits that home. And so DARPA's score, kind of the general objective, is to create confidence scores that get associated with individual papers. Personally, I'm not a huge fan of the word confidence score. I think it implies something a little tricky to explain about whether the validity of it, which is not the approach that we're doing here. But the way to think about it is kind of like a credit score. So you don't pay your bills and you kind of get behind, your credit score goes down a little bit, you pay your bills, suddenly your credit score goes back up. And the idea here, in fact, is that we want to create a score based on replication and reproducibility very quickly and to assess whether social and behavioral science research is how reproducible and replicable it is. They want to do it automated, and then they want to tailor it so that as more information comes in, those scores can be adjusted accordingly. But as we've just shown, right, with both RPP, and there's other studies in the cellular biology, RPCB, and then there's the study that I just talked about that shows, again, that it's somewhat untrustworthy as to kind of what the data is really showing us. But what we really need to think about is how we can evaluate the literature, maybe create a model, and then put applications towards it to get us to more quickly assess this and actually maybe even move innovation forward. All right. So how are we going to do this? This is a huge project. It consists of 3 teams. TA are the technical area teams. The first team to ADA team is what the Center for Open Sciences is what I'm overseeing. And we're essentially the data team. So we're going to be collecting a number of claims from papers, and I'll get into the nitty-gritty of it in a little bit. And then we're also going to be overseeing the reproductions and replications that are going to occur. So we're collecting that data. Then we're going to be sharing that data with the TA2 teams. And these are the experts. They're going to be using expert or prediction markets to see how likely they can predict whether a particular claim will or will not replicate. And then the final team is the TA3 teams. These are the teams that will be creating algorithms to assign the confidence scores based on what we provide for the data set and how successful those expert teams are. Now, one of the things you might be thinking is, why are you engaging experts? Why are you bringing humans into this mix if you have algorithms? Won't they just be able to predict that or be able to write that pretty quickly? And what we found, actually, is that prediction markets are pretty accurate. This is an assessment of the studies, a number of the studies that have been done at the Center of Open Science. So that includes RPP, another social science reproduction project called SSRP, many labs. And the participants that are participating in this market study are traders. They're recruited via community, online community forums. So it can be a wide range. And what you'll see is that at the dotted line going across at 50, anything below that is predicted not to replicate. And then everything above it is predicted to replicate. So the yellow dots are actually the ones that studies that did not replicate, claims that did not replicate, while the greens are the ones that did. And what you see is that the prediction markets were actually pretty accurate. they were much higher than chance, and the rate is at about 70%. So that with kind of information at hand, this is one way that we can enhance the algorithms to further expedite the process of this assessment. All right, now we're going to get into the nitty-gritty of how we are collecting the data for the SCORE project. So the first thing that we're doing is creating a very large database, 30,000 articles from journals that were published between 2009 and 2018. It consists of about 62 journals right now across the social and behavioral sciences. The idea is to get a kind of really wide swath of research. So it's everything from business marketing, demography, criminology, education, sociology, psychology, public administration. We are then going to be kind of enhancing it with the metadata from Crossref and Web of Science. This is predominantly being overseen by a data manager who is really kind of doing a lot of this work automated. So that database is then, we're going to extract 3,000 articles from that database, and it's going to be handed over to research scientists. So I'm working with 4 research scientists in a variety of fields: sociologists, psychologists, political scientists. And so what they're going to do, the first thing is they're going to identify a paper that includes at least one inferential test. So any kind of, and human data on human subjects. So any kind of editorial goes out the window, book reviews go out the window. Those are not things that we're looking at. But what they're going to do is they're going to identify one claim from that paper as it is expressed in the abstract. They're going to identify it, again, as it's expressed in the paper, so usually a hypothesis, the inferential test, and then the test statistics. So you kind of can have this, connect the dots through the paper. Let me reemphasize. It is one claim, not the claim of the paper. Okay? So you can see how in some fields it's going to be a little bit more complex with the multivariable approaches. We're using a program called TagTog. It's an online tagging system. It allows us to highlight and code accordingly, and then we can make some additional notes. Because if you recall, all of this data is going to be passed on to another team, so it needs to be human readable. The researchers only have 25 minutes to do this work. We are doing this at a very aggressive rate. We have to produce about 300 of these claims a month. So they really have limited amount of time from which they can identify these claims. The other thing that we're doing is we're actually engaging the original authors to get feedback on the claim. So we share with them the claim that we've identified and say, do you agree with this? This is a clear link. And we've been getting a lot of, actually, surprisingly, a lot of engagement, about 50%, and that also kind of varies depending on the time of year. So we see some a little bit more or less earlier in the summer than we did later in the summer. And what we're finding is that they're serving as a really great quality check on the work that we're doing. And so, and even with that, we have a pretty low error rate. And when I say error rate, it means that we presented a claim and they disagreed with how we did that trace, or they didn't think that was a good trace at all. And so we were only done of 6.65. And to date, we've gotten 1,000 claims across, or finished, identified, to be handed over to the TA2 teams. Okay, so that's that first level that gets passed on to TA2 teams. The TA2 teams then take just that data and make their predictions. Are they going to be able to replicate, or will they not? The second step that we are doing is what we call the replication and reproduction pipeline. We're going to be selecting from that 3,000 a subset of 300 that we're actually going to replicate or reproduce. And we're doing this with a bunch of collaborating labs, about 600. I'll talk about that in a second. But this process incorporates really getting more data so that we can make it perfectly clear when we hand everything over to the lab what the studies actually, or what the claim is. And this includes basic Google online searching, but we're also emailing the authors again to say, hey, do you have any of your original materials, your original data, the analysis that you'd be willing to share with us? And we've been getting we've just started this part of the process and have been seeing some pretty good engagement from the start. They're going to do a data enhancement, which means they're going to look at the data and very quickly assess, is it absent, is it insufficient, is it sufficient, or is it excellent? So then we can give it a kind of a general score so we know what we're dealing with when we hand this material over. The other thing that we're going to be doing is to ensure high-powered studies. So we're doing a two-stage sampling strategy. The first stage, and we calculate these samples before handing them over to the lab. So the first stage is to a 90% power of 75% of the effect size at 5% level. And if we're after the initial collection of data, we find that it is not significant, then we do a second round of data collection. So then the pooled data between the ones in the two, first stage and second stage, is 90% power to detect 50% of the original effect size at 5%. So we're really trying to ensure the quality of the high-powered of the study itself. Now, one thing I quickly want to do is define replication and reproduction and how we're using it in this study, because I know that words get interchanged and sometimes can mean one thing or the other. And the reproduction and replications here are serving as the ground truth for the prediction markets and the experts. So this is really, really important. First is direct replication. We use this data, we use the exact method and analysis, collect new data to get the same results. We have data analytic replications where we use the original methods, use different pre-existing data set, hopefully, or to try to get the same results. Then we have two types of reproductions. Computational, take your data, code, reran it, we would get the same numbers and graphs. We also refer to this as push-button reproducibility. And then lastly, the robust reproduction, where you take your data, use new analysis, and get the majority of the analysis as statistically significant. Now, based on some of the restrictions and requirements of the project, we actually have to do 100 of the 300 as direct replications, because those are the ones that are going to take the most time to collect, but also because it helps ensure kind of the high-powered component of it and allows for the assessment between the teams to be a little bit more consistent. But the best thing about reproducible work really is not that it's just you repeatedly arrive at the same result, but that you have this organizational structure in place to allow you to require, or rather allow you for transparency and rigor in the work that you're going to be doing. So once we have the study selected, we then pass it on to our collaborating labs. And we're working with Chris Chartier of Ashland University. He's the director of Psychological Science Accelerator. We've got about 600 collaborating labs right now all across the world, which is really incredible to see. And what we're doing on our end is working with the labs to pre-register their study. So again, they have to state the hypothesis, their plan, the methods, all prior to the data collection. And really it's about creating a timestamp documentation, so as the idea exists at the time, and it's keeping ourselves honest, because frankly, we're the ones who can be easily tricked, right? You are the easiest person to trick. We work with them to pre-register the study. Then we also help navigate the IRB and the DoD HSR. So this is a fun little part of our project, is that we actually have 2 HSRs that we have to go through. The first one is the institutional IRB, but then we have to do a secondary HSR using the Department of Defense. And here we're working with the Navy in this particular case, and have to work with their HRPO, which stands for Human Resource Protection Office. Lots of acronyms, lots of acronyms. And lastly, we're going to be working with the teams to write final reports. Again, we're engaging with the authors at all levels and allowing for them to comment on our methods and on our approaches to all of this. So they will even have their own section within the pre-register report as well as the final report final reports for the individual studies, and then a collaborative report at the end of this. And all of this data, or as much as this data as possible, is going to be made public and online via the OSF. So that all of it is going to be able to be transparent and up for debate, and be able to engage in the entire process of this. So you can see that it's actually pretty labor intensive to collect this data. The TA2 teams have just started doing their analysis with the data that we're sending them. And again, we're sending them this every month. But the aspect of DARPA is go big or go home, and they expect results to happen very quickly. So the project is over 3 years. It's 2 phases. We're in phase 1 right now, which is a year and a half. We're already 6 months into it, and so we're supposed to get the rest of the project, or the first half of this project, done by June 2020. To give you a point of reference, we're doing 300 replication attempts in a year and a half. RPP, I think, did 100 in 4 years. So we're trying to accelerate that to help increase the pace of discovery, which will be really, really helpful. And that is if we are successful, if the whole program is successful. It's actually going to be really, really transformative insight into research credibility. And we're going to learn whether reproducibility is intrinsically tied to open data and open materials. So the other thing that I personally think is really exciting and neat is that it could also show us what are we doing well, and how can we amplify all of those things that we're doing well. We have mechanisms in place, and we should encourage that. And encourage that for, as I just said, the pace of discovery, but also the pace of innovation. And it hopefully will encourage everyone to talk about, what does it really mean to have an open workflow? How can we engage in that? But to kind of bring it back to the beginning again, this could really accelerate and improve our disciplines. But ultimately, it is making us better researchers, better discipline, so that we can really get back to the questions at hand, those questions about society, those questions about humanity, and what we're really interested in trying to kind of improve that aspect and that part of our interest. So you can find all of these slides on the OSF, because we keep everything open and transparent. And I'm also happy to take any questions or comments. There's my email, should you be interested. And if you have any questions about the program itself or interested in collaborating, we do collaborations at all levels, not just do the reproduction and the labs, but we're also doing collaborations with the pre-registration, where we're going to be opening it up for all the pre-registrations. We'll go through a review and engaging a variety of individuals from the community to kind of get feedback on it. So without further ado, I'd like to open up the floor, and if you have any questions about any of this or the project in particular, I'd really like to hear from you.